Welcome back. Now we're going to talk about the MapReduce framework and the next generation framework, YARN, in this lecture. The software MapReduce framework is essentially the software framework which was originally developed for parallel processing applications under Hadoop. The basic idea was that the job is splitting data into chunks, and these chunks are processed by the map tasks, which are laid out across the all the compute nodes. And once the map tasks are done processing these individual chunks of data, and they are independent chunks of data, the framework sorts the output from this, and the reduce tasks will use this sorted map data as input and perform some more operations, reduction operations on them, and then that gives you the output for the entire program. And pretty much all the applications that were developed in the original Hadoop framework use this approach. Now, the advantage was typically the compute and storage nodes are the same. So your map tasks and your HDFS daemons for the data nodes are essentially running on the same nodes. This means that you can schedule tasks on nodes which already have data present. And this is really important if you're looking for scaling, because you're not moving data around between nodes, you're actually computing where the data is. Now, how was this achieved on the actual framework originally? There was a single master job tracker, and this could be on a master node. The job tracker essentially does the scheduling and of the tasks on the compute nodes, and it actually monitors how the tasks are progressing, and in case there is a failure, it will re-execute the task and follow up on the task essentially. Now, on the compute end, on each node there is a task tracker, and its job is to get the requests from the job trackers and process them. So it might get map requests, and the mapping tasks are done on the node, for example. And you might have a lot of tasks flowing through as part of a given job. So putting it all together, this is the original Hadoop architecture. Essentially, you have the HDFS components and the MapReduce framework components all together. So you have the master node with the job tracker and the name node, which is essentially the HDFS handler. And you have the compute nodes and the data nodes. And typically, as we mentioned, the compute and data sit together on the same node. Now, on each so the job tracker is the main handling daemon for the map and reduce tasks. So this sits on the master node, and it will initiate tasks on the task trackers, and then it basically communicates to keep track of the tasks and how they're progressing. And as we saw in the previous slide, if there's a failure, it can restart and things like that. Now, on each of the compute nodes, you have HDFS components too. So you have, because these are data nodes, and a file is typically split up into blocks that are stored on these data nodes. And then the metadata for this is handled by the name node. So the key takeaway is that you should always try to co-locate the compute with the data, so you're not moving data around. So now we go on to the next generation of this MapReduce framework, which is called YARN. The main idea is to separate the resource management and the job scheduling and monitoring. So you have a global resource manager, and then you have a node manager on each node. And now the different thing is you have an application master on each on certain nodes, and we'll talk about the architecture a little bit more. And you'll have one application manager master for each application. So if you look at it as an architecture diagram, this is how it looks. So you have a resource manager, then you have node managers on each node, and the resource manager basically gets job requests from the clients, node status from the node managers. So if you look at it in this picture on the left, you have the two clients in red and purple, and they might send some job requests to the resource manager, and then it also gets the status from node managers about what resources are available, and it also communicates with application masters about the status of applications essentially. Now, there are two components in the resource manager. There is a scheduler which is essentially responsible for allocating resources to the various applications that are running. So these are essentially with the constraints of capacities and the queues and things like that. And there are policy plugins available for the scheduling aspect of it. So you could have a capacity scheduler, or you could have a fair share scheduler, things like that. Now, there's an applications manager component in the resource manager, and all it does is negotiates the first container for the application. So in this picture, you'll see the application master on the nodes, and it also restarts these if there is a failure. But the actual job management is now being done by the application master. So you see all the purple colored boxes here essentially circled in this diagram. So in this case, the application master is on the first node, and it's negotiated a resource container on the second node, and it's going to track how the execution goes there. And if there are more containers on other nodes, it's going to track all of them. So essentially, you broke out that piece from the original single job tracker, and now you have these application masters on certain nodes. So that was a big change in design, and it lets you do additional things in terms of the types of jobs you can run. And now there are other additional YARN features. There is a high availability resource manager. So as you can see from the picture, it looks like we have one single point of failure with a resource manager. But there is actually a high availability option in the newest Hadoop releases, and this is in form of an active standby resource manager. So if one of the resource managers goes down, the standby one will come up and take over the management. There's also a timeline server, which basically allows for storage and retrieval of the application historic information and current information. And this can be specific to the application, or also generic info about completed applications. So this is good if you're trying to see, how a job ran, how many tasks, map tasks were there, how many reduced tasks were there, what were the resources used, things like that. YARN also now has ability to use C groups, which is a Linux feature to manage resources used by the containers. You can have secure containers with restrictions to particular users. And there are web services available that lets you give you access to cluster, node application, and historical info on those kind of things.